Hi, this is Bill Punch from Michigan State University. This is another video in the series of videos, the Introduction to Computer Science Using Python, CSE 231. In this video, we're going to take a look at writing our own functions, the advantages of having our own functions and how they work. Let's go ahead and get started. So we've used functions quite a bit already in our work. The example that we have is if we import the math package, we get, as an example, the square root function. If we apply the square root function to the value 9 contained in parentheses, we should get the value 3.0 back, which is exactly what we did. We can ask ourselves some questions, though, which we may not have asked before. Just exactly how does square root do its job? What are the details? The answers are we don't know. The details are hidden from us. Right? We know we send in the value 9, square root operates on it, gives us back another value 3. The idea of hiding these details is called encapsulation. The square root operation encapsulates or covers together the idea of how the square root is calculated and gives it to us, the users, as just a simple call to a function. This actually has a number of advantages for us if you take a minute to think about it. First, whenever I need to call the square root function, it's easy to reuse, I simply call it. So anywhere in my code, I can simply stick this thing down, get a square root function whenever I want it. If, imagine that I had to write all the details everywhere I needed to invoke the square root function in my code, it would make my code very bulky and difficult to read. By encapsulating the concept square root and placing it in the code where I need it, my code is made much easier to understand. Finally, and though proven may be a rough word, whoever wrote this square root function for the Python library has looked at this a lot harder than we would and shown it to be correct. He may not have proved it, but he feels confident about it. Other people have looked at it, tried it out, made sure that it does what it's supposed to do, so we can use it with confidence to solve this particular problem. What is the square root? We would like to gain all these advantages by writing our own functions, and that's what we're going to do today. For the example, in this video, we're going to use something very simple. We're going to convert Celsius, a temperature reading in Celsius, to a temperature reading in Fahrenheit. Here's our function to do that. I'm going to show it to you, and then I'm going to tell you how it works. If I evaluate this, nothing happens. In fact, what did happen was, and you should know that, is that up to this point, we know that equals, or assignment, puts a value into our namespace. Right. The def keyword is another way to put something into our namespace, that is a function name, Celsius to Fahrenheit. So now Celsius to Fahrenheit is defined in our namespace as a function. How does it work? Let's take a look at this picture. Right. When we make a function, we have a couple of elements. First, there's the def keyword. That's an indication that we're defining a function. Some name. The name has to follow all the regular naming rules for Python. Parentheses, and parentheses indicate the creation of a function, and then a series of what are called parameters, elements that we're going to use inside of our function when we make a calculation. And then, as always, for a header statement, a colon. Underneath then is the suite of the function. These are the elements that we're going to run when the function is run. In particular, there's a special word called the return statement. When the return statement is executed, the expression associated with it is returned and the function ends. So that's the general way we would define a function. Having defined a function, we can now call it. We define the name Celsius to Fahrenheit as a function name. You invoke a function with parentheses and we send in a value, in this case 100, and we're going to print the result. It does what we're supposed to do. 100 Fahrenheit is 212 Celsius. Again, the picture, right? We can set a value, in this case a temp, for example. We call the function, we know what its name is. We have to have defined it first. We pass in a value. The function runs and it returns a value. We can grab it in an assignment statement or we can print it out. Just how does this work? What's the flow of information here between caller and definer? So here's a picture. It goes in the following way. Here is the main program. We invoke the function Celsius to Fahrenheit. We pass in a value. It's associated with the variable a temp. What happens? This program, wherever the main program is, halts temporarily, or suspends, if you will, and we pass control to the function Celsius to Fahrenheit and do whatever it says to do. So the main program here is halted, waiting for a result to come back from Celsius to Fahrenheit. The value in this argument is now passed to this parameter. So whatever was associated with a temp in the calling is now associated with temp in the function. So in this way we pass information from the call to the defined parameter. Once control transfers, we run the suite of the function. It's evaluated until it hits a return statement. When it hits the return statement, that means the function is going to end, and then the calculation or variable value or whatever is associated with the return function is passed back. The function ends at this point. The value is passed back as the result from calling this function, and we can associate it with a variable, in this particular case, f.